right, section 3.8, C structures. This is a short section from the book Real-Time Computing for Mechanical Engineers. I'm Picone, Garbini, and Devine are my co-authors. We wrote this book with the MIT Press, and rtcbook.org is the companion website for the book. Okay, C structures. We pause this communication chapter to learn about C structures before taking up I/O programming of the target computer, which we're about to do. This is necessary because that programming will require an understanding of structures in C. These are used to group information that belongs together. The quintessential example is the tuple, coordinates that define a point. Okay? The example at right shows some of the syntax. So we have a main function, and we're going to declare what a point is. So point is a struct, a structure. We have two elements in the structure, a double called X and a double called Y. In the next line, we initialize and declare pt1 to be a point struct, which we just declared above, and we give it an initial value of 1.2, 4.5. So we've initialized this point to have two doubles, x being 1.2 and y being 4.5. In the line after that, so we did this, in the line after that, we declare an instance 0.2, but we did not initialize the values. So in the following lines, we will assign to 0.2.x a value of 2 times 0.1.x and 0.2.y a value of 3 times 0.1.y. So we see here how to access values in a struct and how to assign to them as well. We then do a quick print of 0.2.x, 0.2.y, and we get 2 times 1.2, or 2.4 as x, and 3 times 4.5, or 13.5 as y. The two double members are grouped inside the structure tag, so these are the two members, x and y. They don't have to have the same type, but they do in this case. An instance of a struct can be initialized at declaration, like we did in this line up here, or we can declare an instance, as we did for 0.2, and later assign the values. You can also have nested structures. You can have a struct inside of a struct. C structures can also be nested. For instance, a line segment can be defined by 2 points. We defined what a point was. Now we'll define what a line is, as shown in the snippet at right. So a segment is going to be defined by 2 points, 0.1 and 0.2. And we're declaring seg1 to be such a struct. Note that the specific member names within a struct, so pt1, pt2, can be used in other structures without conflict. So pt1, pt2 for seg1 are declared here, but we could use pt1 and pt2 for seg2 as well. Furthermore, the syntax that declares seg1 can be used to declare further segments as well. A function can be passed or return a structure as an argument, a pointer to it, or each of its members separately. So we can use them pretty much like we would use any other variable. Okay, so in our interface with UARTs, we're going to be using some structs. So look forward to that in the next section. I'll see you then.